Modern cosmology is built primarily around gravity. Gravity forms the stars, gravity shapes the galaxies, gravity bends space-time itself. When observations fail to match expectations, additional invisible entities are introduced, dark matter, dark energy, and inflationary fields, in order to preserve the gravitational framework. Yet, increasingly astrophysicists are forced to acknowledge another player: magnetism. Magnetic fields are now said to thread galaxies, shape star formation, influence black holes, sculpt jets, and permeate intergalactic space. Enormous filamentary structures spanning cosmic distances are routinely described in magnetic terms. But there is an awkward problem at the heart of this discussion. Magnetism does not exist independently of electricity. Every magnetic field arises from moving electric charge. Magnetism is not separate from electricity, but one aspect of a unified electromagnetic phenomenon. And yet, despite the growing importance of magnetism in astrophysics, electricity itself often remains curiously absent from the conversation, treated as secondary, negligible, or somehow neutralized away on cosmic scales. Why? Why does modern cosmology increasingly invoke magnetic effects while remaining deeply reluctant to discuss large-scale electrical processes? And why does the electric universe place electricity at the center of cosmic behavior? The answer reveals a deeper divide, one between observation and abstraction, between laboratory plasma behavior and mathematical idealization. One of the most common objections raised against the electric universe is the claim that plasmas are, quote, quasi-neutral. The argument goes something like this. Because plasmas contain roughly equal numbers of positive and negative charges, large-scale electric fields cannot exist. Therefore, electricity cannot play a major role in cosmic structure. The conclusion is treated as settled fact, but notice what has happened here. An observation has quietly been transformed into an assumption. Yes, plasmas tend toward equilibrium. Charges redistribute themselves dynamically. Regions of imbalance attract compensating charges, but equilibrium is not the absence of electrical activity. In fact, it is electrical activity. The continual movement and redistribution of charge is precisely what electricity is. A thunderstorm tends towards equilibrium. A capacitor tends towards equilibrium. The sun also tends towards equilibrium. None of these systems are electrically inactive. Quote, plasma cosmology begins with the experimentally verified fact that plasma electrodynamics dominates the observable universe. End quote, Anthony Peratt. Plasma does not eliminate charge separation. Plasma responds to charge separation, and because plasma is electrically conductive, even tiny imbalances can drive enormous currents across immense distances. The universe does not need gigantic static voltages sitting motionless in space. It needs electrical circuits. That is exactly what laboratory plasma demonstrates. In plasma laboratories, electrical behavior is unavoidable. Double layers form spontaneously, filaments twist into helices, current channels pinch themselves into narrow strands, plasma self-organizes into cellular structures, rotating vortices and luminous discharge patterns. These are not theoretical speculations, they are observable behaviors. Christian Birkeland demonstrated filamentary electrical currents more than a century ago. His Torella experiments reproduced auroral forms in the laboratory. Later, researchers expanded on these observations repeatedly. Yet astrophysics gradually drifted away from laboratory grounding and deeper into mathematical abstraction. Magnetism became detached from its electrical origins. Magnetic field lines became treated almost like physical strings suspended in space. Scientists began speaking of field lines breaking and reconnecting, as though contour lines on a map had somehow acquired physical substance. Even Hannes Alfvén, pioneer of magnetohydrodynamics and Nobel laureate, eventually warned against this trend. In his Nobel acceptance speech, Alfvén stated, quote, "I thought the frozen-in concept was pedagogically useful. In reality, however, it turned out to be a dangerous pseudo-pedagogical concept." End quote. He warned that elegant mathematics can create the illusion of understanding while obscuring physical reality. In an age increasingly dominated by theoretical abstraction, that warning resonates powerfully. Astrophysics often describes gigantic magnetic structures spanning galaxies and galaxy clusters. Yet magnetic fields do not emerge from nothing, they require currents. This raises an uncomfortable question. If immense magnetic fields permeate the cosmos, where are the corresponding electric currents? The electric universe argues that the answer is hiding in plain sight. Filamentary plasma structures observed throughout the universe strongly resemble Birkeland currents produced in laboratory plasma experiments. Recent astronomical observations continue to reinforce this possibility. In one recently discussed study published in Monthly Notices of the Royal Astronomical Society, researchers observed enormous rotating filamentary structures extending across galactic scales. Initially, some scientists reportedly suspected the data itself might be flawed because the rotational behavior was unexpected. Yet the structures remain long, coherent, rotating plasma filaments spanning immense distances. To electric universe proponents, such formations appear deeply familiar. Birkeland currents naturally twist, rotate filaments, and self-organize through electromagnetic forces. Rotation is not anomalous in plasma discharge behavior. It is expected. Discourse analyst Chris Reeve, who runs Controversies of Science on X, has documented many such rhetorical maneuvers that often accompany mainstream commentary on such topics. The mainstream response frequently attempts to preserve gravitational models by introducing additional layers of invisible entities, dark matter halos, hidden mass distributions, and exotic turbulence mechanisms, or hypothetical magnetic processes detached from obvious electrical origins. Even the terminology can become a form of conceptual distancing. Phrases such as ion storms, electron rains, and plasma winds frame electrical phenomena in the language of fluid dynamics, subtly obscuring their electrical character. Again and again, the electrical interpretation remains the least discussed possibility. One of the deepest misconceptions in modern astrophysics may be the treatment of magnetism as a primary driver rather than as evidence of electrical activity. A magnetic field is not an independent cosmic substance. It is the signature of moving charge. Even an ordinary bar magnet owes its magnetism to electrical processes, electrons spinning and orbiting within atoms, creating tiny current loops known as Amperian currents. Electricity and magnetism are inseparable. Yet, in cosmology, magnetism is often granted center stage while electricity is quietly removed from the script. Why? Partly because magnetic fields are easier to measure remotely. Magnetometers can detect magnetic field signatures from great distances. Measuring distributed electric fields in diffuse cosmic plasma is far more difficult. This creates an observational bias. Researchers naturally focus on what is easiest to detect. Over time, the measurable effect becomes mistaken for the underlying cause. The fingerprint replaces the hand. Much of mainstream cosmology still implicitly treats space as though it were essentially empty, an inert vacuum interrupted occasionally by particles and radiation. But plasma changes everything. Plasma is not merely gas. It is an active electromagnetic medium capable of collective behavior. Quote, and even if one regards the electric fields as merely another postulate, it has the great advantage that it is the one postulate which, in my view, renders all the others unnecessary. End quote. C.E.R. Bruce. In plasma, local interactions can organize large-scale structures spontaneously. Filaments attract and repel one another. Currents self-confine through magnetic pinch effects. Rotating structures emerge naturally. Even simple plasma globe demonstrations reveal astonishing levels of organization. Filaments dance, branch, twist and reconnect dynamically. Charge distributions continually rebalance themselves. Regions of apparent equilibrium emerge only through ongoing electrical exchange. These laboratory behaviors are not curiosities. Plasma comprises more than 99% of the visible universe. If electromagnetic behavior is fundamental to plasma physics in the laboratory, on what basis should it be ignored in the cosmos? This is the central question. The standard cosmological story claims that, after the Big Bang, protons and electrons eventually combined into neutral hydrogen atoms as the universe cooled. From there, gravity supposedly became the dominant architect of the cosmic structure. But this picture quietly assumes that electrical behavior somehow ceased to matter once neutral atoms formed. Yet neutral atoms are not electrically inert in any absolute sense. Plasma reappears easily through ionization. Stars, nebulae, solar atmospheres, galaxies, and intergalactic space all contain ionized plasma environments. The universe did not leave electromagnetism behind. Indeed, the universe appears saturated with plasma activity. The electric universe perspective asks whether cosmology may have prematurely relegated electromagnetism to a secondary role because gravitational theory became mathematically dominant during the 20th century. Gravity governs orbital motions elegantly, but plasma governs structure formation extraordinarily efficiently. Electromagnetic forces are vastly stronger than gravity. Even small charge separations can dominate plasma behaviors. This does not eliminate gravity, but it may radically alter our understanding of cosmic dynamics. Comets provide another revealing example. Conventional models describe comet activity largely in terms of sublimating ice heated by sunlight. The electric universe instead emphasizes plasma interaction and electrical exchange. As comets move through varying electrical environments near the Sun, discharge effects, filamentation, X-ray emissions, and sharply defined jets may arise naturally through electrical processes. Critics often dismiss this outright because comets are assumed to be electrically neutral bodies. Yet, plasma interaction experiments repeatedly demonstrate that electrically active surfaces can produce highly structured discharge behavior under changing plasma conditions. Again, the question is not whether charge balance exists overall. The question is whether dynamic electrical interactions dominate the observed behavior. The electric universe argues that they do. Recent observations of Comet 3I Atlas have only strengthened that case. Its striking forward-facing tail, sunward plume, is precisely the kind of behavior expected in an active electrical environment, a classic plasma discharge signature, not merely passive ice sublimating in sunlight. At its core, this debate is not merely about electricity versus magnetism. It is about methodology. Do we begin with theoretical assumptions and force observations into compliance? Or do we begin with observed behavior and allow theory to follow? The electric universe approach insists that plasma should first be understood through experiment and observation. Laboratory plasma forms filaments. The cosmos contains filaments. Laboratory plasma forms rotating current structures. The cosmos contains rotating filamentary structures. Laboratory plasma produces cellular organization, double layers, jets and discharge effects. The cosmos displays all of these phenomena in abundance. As plasma physicist Anthony Peratt wrote in an IEEE paper in 1986, quote, "Plasma cosmology begins with the experimentally verified fact that plasma electrodynamics dominates the observable universe." End quote. The cosmos is trying to tell us something extraordinarily important. Perhaps we should listen. Quote, electric currents in plasmas naturally form filamentary structures capable of transmitting energy and momentum over vast distances. End quote. Anthony Peratt. The electric universe does not reject magnetism, quite the opposite. It insists that magnetism cannot be separated from electricity. To focus exclusively on magnetic effects while dismissing electrical causation is to study only half of the phenomenon. The universe is electromagnetic. This simple statement carries profound implications. As Birkeland understood more than a century ago, cosmic plasma is not passive dust drifting through empty space. It is active, dynamic, and electrically organized. Quote, it seems to be a natural consequence of our point of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds, and we have assumed that each solar system in evolution throws off electric corpuscles into space. It does not seem unreasonable, therefore, to think that the greater part of the material masses in the universe are not in the solar systems or nebulae, but in empty space. End quote. His fellow Scandinavian Hannes Alfvén later warned that elegant mathematics can sometimes seduce science away from physical reality. The question is not whether electricity exists in space. It plainly does. The question is whether modern cosmology has systematically underestimated its role in shaping the universe itself. If so, then one of the greatest organizing forces in the cosmos may not be hidden at all. It is simply hiding in plain sight. This 12th episode brings our Misconception series to a close. Over the past couple of years, I hope we have helped clarify and perhaps answer many of the questions and misconceptions surrounding the electric universe and plasma cosmology. And that's a wrap. Ciao for now.